We had a pretty good run with those exercises involving one-dimensional arrays, so let's go ask ChatGPT for exercises involving 2D arrays. I also am interested in knowing about any exercises involving three-dimensional arrays, but I guess we should start small. So let's start with 2D arrays. This is another subject where over the years I've found it harder and harder to come up with my own exercises involving 2D arrays. I sort of run out of ideas. There are a few subjects that my mind immediately goes to when I think of 2D arrays. So as I'm sure all of you know by now, I really love linear algebra, and I always think of linear algebra exercises. But you know, that's our assignment, so I can't very well go and do exercises on linear algebra as practice. That would sort of ruin the assignment. And I'm hoping ChatGPT has a different take on that and can give me some other exercises involving 2D arrays that aren't linear algebra based, because that's where my mind always goes. So I want some practice working with multi-dimensional arrays in C. Can you generate 3 programming exercises involving 2D arrays? So I'm going to add one qualifier here, which is that we're just about at the point in the course when we want to begin talking about text or strings of text, which is an array-related topic. But I'm going to tell it specifically I want arrays involving numerical data, because I don't want it to get mixed up and to think that I want arrays involving strings of text, because we just aren't ready to do those exercises yet. I don't know about strings of text yet, so please don't generate exercises involving strings. All right. Of course, here are 3 programming exercises involving 2D arrays in C. Okay, I can already see a problem. Okay, so exercise 1, matrix addition. Okay, so because I'm trying to avoid doing linear algebra exercises, because first, we've already seen a couple of them in class, and second, you know, that's the assignment, I'm going to veto exercise 1. Exercise 2, finding the largest element. Okay, this looks pretty good. This is a nice fundamental 2D array exercise. I will do this. Exercise 3, transpose of it. No, not going to happen. I don't want to do any exercises involving matrices or linear algebra. And I'm gonna give it a disclaimer. I do really love linear algebra in general. I just don't want to do any programming exercises involving linear algebra. Okay, just so I don't want it to get the false impression that I don't like linear algebra. Can you regenerate exercises 1 and 3? All right. Of course! Here are the modified versions of exercises 1 and 3. Exercise 1, sum of elements in a 2D array. Okay, yeah, fine. I guess I'm so particular. I guess I have to go do this. I feel like this is on the easier side, but I think fair enough. We can go do this. Exercise 3, okay. I just said no matrices. I sort of want it to learn a lesson here. I mean, I did say no matrices or linear algebra, so let's try it again. The new exercise 3 involves matrices. I specifically said that I don't want to do exercises involving matrices or linear algebra. I want to say, like, what gives? At this point, am I supposed to be asking for ChatGPT's manager or something? Can you regenerate exercise 3 again, and keep in mind that I don't want anything involving matrices or linear algebra. And it's going to apologize. Now I feel bad. Okay. Okay. So it feels bad about that, so it's going to try and give me way too much information. Write a C program. So this is called character frequency counter. Write a C program that takes a 2D array of characters. Okay, that's interesting. A 2D array of characters as input. The program should then count and display the frequency of each character present in the array. Ooh, okay, that's a bit of a challenging exercise. It's not challenging because of the 2D array part of it. It's challenging because of how I can display the frequency of each character present in the array. But okay, I remember rejecting an exercise a few weeks ago that was essentially this, but without the 2D array aspect. And again, I'm being so particular, at some point I just have to settle down and do the exercise. I can't keep complaining. Okay, so I guess we've got 3 exercises. The first one is, let's see, finding the largest element. This other exercise I already rejected, I think for good reason. So I'm going to start with this. Write a program that takes a 2D array as input and finds the largest element in the array. It says here it takes a 2D array as input. Now, as usual, it's being a bit vague about what it means when it says as input. I could interpret this 2 different ways. I could interpret this as read the array from the user, so have the user enter in a full 2D array. That's one way of providing input. Or I could just hard code the array into the program. I would argue that what ChatGPT probably means here, if I ask it for clarification, it will probably want me to read it as user input. I am actually not going to do that. And the reason is basically just practical. It's because if I have to type in a full 2D array every time I test the program, the video is going to take way too long. So instead, I'm going to hard code my 2D array into the program. And the reason I think that's an acceptable simplification is we've already seen, even in this series of videos, a few examples of reading data into arrays from user input. So I suspect if we wanted to read the array from user input, we could easily add that feature later. So for now, what I'm going to do is I'm going to write a program that has a 2D array sort of built into the program. So I'll make the array, it's going to be called A. It'll have, let's say, we'll start with 3 rows and 2 columns. And so I'm gonna initialize it using this curly bracket initializer, and then inside the initializer, I'm gonna initialize each of my rows. So there's gonna be 3 rows, each row is gonna have 2 columns. Jupyter Hub really doesn't like the indentation that I'm trying to achieve here. So there's the first row there's the second row. Okay, it doesn't give me a choice but to indent over there. There we go. And then there's the third row. So we'll do negative 111, 116. So I've got at least one negative value in my array. Okay, so there's my array, 3 rows, 2 columns. I'm going to, actually, you know what I'll do? I'm going to make variables to store the number of rows and columns. Rows equals 3, columns equals 2. And then when I initialize the array, I will use those numbers. And that way, if I change them, that should be reflected, or at least the compiler should give me some kind of a warning if I change the number of rows and I forget to change how many entries are actually in the initializer. Okay, so I'm going to have to test out, obviously, other sizes of array here. Write a program that takes a 2D array as input and finds the largest element in the array. Now, it doesn't just want me to print out the largest element. It does, I mean, that's one of the things I need to print. It also wants me to keep track of where I found that largest element. So I have to keep track of the row and column index of where that largest element was. Now, there are a few ways I could interpret the need to print all 3 of those pieces of information. So here's my array here. What I could do is I could have 3 variables that I keep track of, which is the row number, the column number. I guess I'll draw in my row numbers and column numbers. I could keep track of the row number of the row where I found the largest thing. Of course, the largest thing is this. I could keep track of the row number and the column number, and I could keep track of the value itself. So I have 3 variables: row number, column number, and value. But on the other hand, if I have the row number and column number, I can always go grab the value whenever I want. And so I think here I'm going to use only 2 variables. I'm just going to keep track of the row number of the largest value I've seen, the column number of the largest value I've seen, and that's it. If I ever need that value, I can just go grab it by using the row number and column number. But my instinct here is that by having fewer variables, I avoid redundancy. If I have 3 variables where one variable just stores the value, I run the risk of having that value I'm storing get out of sync with the row number and column number. And I want to avoid that because that could be a source of bugs. In a broad sense, if you're designing a solution to a program and you think you need lots of variables, then go right ahead. If the program works, if the solution you're coming up with makes sense to you, then implement it. There's nothing inherently wrong with using more variables versus less variables. And certainly you shouldn't have a mindset that using more variables is bad or slow or has a performance issue. That basically isn't true, especially in a case like this. My instinct, though, is that the way I'm visualizing the problem, I can think of any element in an array just using its row number and column number. Okay, so what I'll do is make variables to store the row and column number of the largest value. So I'll call them largest row num, and I'm going to start this at -1. and that's deliberate. So these are going to store the row number and column number of the largest value that I've seen. But at the moment, as of line 23, I haven't seen any values at all. I have not yet actually looked in my array. So I'll set these to invalid indices. So -1 is not a valid index. And then as I go forward, I might change this. But as I go forward, I can use the fact that if largest row num is equal to -1, that means I don't actually know what the largest value is yet. I haven't seen any values. Now, the more I think about it, though, the more I realize maybe I can approach this in the same manner as I would approach finding the largest value in a 1D array. So if I have a 1D array, I don't know, there it is. If I have my 1D array and I'm going to have this one be 0, then what I did in a previous exercise was I said, I'm just going to walk from left to right. And when I start, I'm going to assume that the only element I know of, which is this 6, this is the largest element as far as I know. And then as I walk forwards, keep going to the right, I will update my view of the world. So as I see each new element, I will compare it to the largest thing that I've currently seen. So I guess I could do that here. I could say, as far as I know, the largest row and column, or the element that's the largest, is just whatever the first element of the array is. So if I'm working with this big 2D array, then I could say, well, until I've looked at any other elements, this top left element, that would be row 0, column 0, is the largest thing that I've seen so far. Okay, so I think I will approach it that way. And so I may actually backtrack on my -1 gimmick when it comes down to it. But first I'm going to write the loops I'm going to need later. So I'm going to write 2 loops to loop over the array. I think I can do this entire exercise with 1 iteration over the entire 2D array, so 2 nested loops. I'm going to use j and k for this. So I'll say int j is 0, j is less than the number of rows. So I typically like to write nested loops where the loop over rows is on the outside, and then j++. Okay, and then the inside loop will be looping over all the columns. So int k equals 0, k is less than the number of columns, k++. All right. Okay, so I guess my goal here is compare the element at row j, column k with the current largest known element. All right, so that's my goal. I'll clear out this diagram. And now I think about how I would do that. And I guess inside this for loop, what I would do is I would say if a of row j, column k, is greater than the current record holder, which would be at the largest row number, largest column number, then I guess that means that row j, column k is the new record holder. So that means that that means I'm going to set that row number of my largest element and that column number of my largest element to be row j, column k. So largest row num equals j, largest column number equals k. Okay, so I think this is the loop I need for the algorithm itself. I'm going to now put the print statement at the end. The largest element is, and I'll print out the element, at row this and column that. Okay, so I'll print out, if I want to print the largest element itself, I have to go into the array at this index. So largest row num, largest column num, that would be the index of the largest element. And so I just print that out directly. I'm going to split the print statement over multiple lines. And then I print out the row number by itself, and then I print out the column number by itself. Okay, and now back up to my observation from earlier, which is what I could do if I'm working with some 2D array is I could say, look, before I've done my loop, I'll just assume that index 0, 0 is the largest thing. And then I may update my impression as time goes by, but at the beginning, until I've seen any other elements, I will just assume that the top left element is the largest. Now, unlike in the 1D array case, it's not really trivial to adapt this loop to avoid doing a little bit of extra work. So in the 1D array case, if I'm finding a maximum and I'm using this logic where I say, okay, assume that the first element is the maximum until proven otherwise, then I could just start my loop at index 1. When I iterate over all the other elements, I could ignore index 0 because I've already taken that into account. I don't really have that option easily here. So you'll notice if you stare at these two loops that there is going to be a case where j and k both equal 0, even though really I've already attended to index 0, 0. So I'm actually doing one redundant comparison, and I don't care. The computer's time isn't really worth enough for that to be a problem. And it certainly isn't worth me trying to tie myself in knots trying to find some way around that. So I'm going to leave this the way it is and then run it and see whether the testing that I do reveals that there's anything else I have to add to it. Oh, yes. Okay. So this is an error that we don't need to worry about too much in this course, but basically what it's saying is if you're going to use the curly bracket initializer, so if I want to set the initial elements of the array to be some values, then you're not allowed to have the size of the array apparently be variable. And it really isn't. I mean, I obviously wasn't setting rows and calls based on like the user's input or something, but the compiler is pointing out a sort of contradiction here. If the variable rows ends up being 5 or something, then what are you initializing? You're initializing me with 3 rows and 2 columns. So to get around that, I can just set rows and columns to be constants. Oh, it's still going to complain. Okay, well, we'll just do it manually. All of my good intentions for trying to keep the system flexible, and it's not going to like that. Okay, so we'll do that. Fair enough. So the idea here is that in that initializer where I gave it a size, it really didn't like the fact that the thing inside the square brackets wasn't an actual number. There are a few other ways of getting constants to work in that context, but for the sake of this exercise, we'll just keep going from here. Okay, so practice 2D arrays 1. Okay, so there we go. Largest element is 187 at row 1, column 1. Now, as usual, we should look at this with a critical eye and decide whether the test that I've just done is really going to tell me that much. One thing I'm observing is that it just happens, as a weird coincidence, that the row number and column number were the same in this particular example. That's a little bit alarming. How do I know that I've got the row number and column number correct? So what I'm going to do here is I'm going to begin by putting the largest element somewhere else. I'm not going to press page down if I can avoid it. And I want to make sure that I at least test it on a case where the largest row number and the largest column number are distinct. So I'll run this again. There we go. Here it's at row 2, column 0. Okay, so I moved it. This is row number 2, column number 0. Okay, let's put it somewhere else. Now what I'm going to do is I'm going to set almost all of the elements to be negative. And I want to verify that even if I have a relatively low magnitude value like 10, that obviously is the maximum value. I want that to come out. So that's row 0, column 1. There we go, row 0, column 1. Okay, so I think I've done enough testing now. I guess we'll do one more. So here's 66. I want this to be row 0, column 0. Okay, I've done enough testing now that I think on this size of array, it's reasonably likely that the code is correct. I'm going to undo some of that negative stuff that I added. Now I want to test out on arrays of different sizes. I think what I'm going to do is expand out to using 4 columns instead of using 2. Okay, so we'll do 20, 23, 8, and then I'll just make up some numbers here. Let's do 445. And then we'll do 485. And so in this one, the maximum is definitely going to be here. And then today's date is the 24th of August. Okay, so I've got 3 rows and now 4 columns. And I'll come back at the end to that weird issue I had a minute ago with the constant array initializer. But for now, we just want to get this testing done. All right, so the largest element is at row 0, column 2. That checks out. I'm going to try let's make this element larger. This would be row 2, column 2. Okay, that looks good. And let's try row 2, column 3. So we'll just make this number really big. So that's the bottom corner of the array. That looks good, row 2, column 3. And then we'll just do one more in the middle somewhere. Let's do this one here. This would be, actually, no, that's row 1, column 1 again. That's not as interesting. Let's do this one. So that's row 1, column 0. Okay, it looks like that works as well. And then as one final test case, I do also want the test on what happens if I change the number of rows. So here, what I'll do is I will stick with, I'm going to have 3 columns and 4 rows. So I'm sort of transposing this. All right, and then it's going to do this thing where it doesn't like the way I'm trying to indent it. 7, 8, 8, 8, 8, 8, 9. Okay, so this number should now be the largest. Oh, actually, no, I got rid of my 9917. Maybe we'll just make it a bunch of 9s in a row. There we go. Okay, so now the array has 4 rows, and it should have 3 columns. All right, so there's 3 columns, 4 rows. There we go. Okay, so the largest element is this number at row 3, column 1, which looks good to me. And I could do more tests here, but I think that by shifting the size of the array a couple of different times and observing that there's nothing in this loop that seems overly sensitive to the specific number of rows and columns, so as long as I try it on a couple of different values for the number of rows and columns, I can be somewhat confident. I guess there's one more special case I want to check, which is what happens if the array only has one row and one column? That's weird, but I mean, that could happen. A 2D array could just have one row and one column. I could go further and try and test it exhaustively on cases where it has one column and a bunch of rows, or one row and a bunch of columns. Okay, here it is. Largest element is 6 at row 0, column 0. Okay, I think that's sufficient for our purposes. Now, before I move on to the next exercise, I want to talk a little bit about that strange issue I had a few minutes ago with this. So I tried to initialize this, and as you noticed, I made a bit of a mistake there because I thought that I could just make the variables constant and this error would go away, and that's actually false. And I'm going to blame that on the fact that I have to write so many different programming languages on a day-to-day basis that sometimes things slip through the cracks. But maybe we should ask the question of whether what I did to fix the problem is a good solution. So at the beginning of the exercise, I actually said, I don't want to do this. I don't want to have constant numbers sitting inside the square brackets because that's going to make it hard in case I change the number of rows or columns to keep things consistent. So an example would be, what if I change this to 5, but I forget to change this variable to 5? That could be a huge mess because now the array's size versus the size that I think it is when I do my loop are different. And so there's inconsistency. I obviously want to avoid that. So I feel like my heart was in the right place when I did this. The problem is that it didn't work. So is there a way of getting this effect? What I want is the ability to give the number of rows and the number of columns a name, but I'm now aware that the compiler doesn't like it if I try and give it a variable, because it says, sorry, I don't understand what to do with this. This variable could theoretically change when the program is running. There is a solution, a technique that is valid and people still use all the time in C, but that we often shy away from in this course. I am allowed to define a constant. Normally in this course, I want to define constants using this notation. So if I would like to give a name to a number, I write const in front of a regular variable declaration. The reason that I like that so much is that now rows gets to participate fully in any scoping that's occurring, for example. It behaves just like a regular variable. It has a well-defined type and a scope. It's just that it's constant. You can't change it. I think that's great. And I think in general, when you want a constant, that's what you should use. But there are cases where this other style of constant I'm about to mention could be useful. And so I'm going to write up here, I'm just going to write some stuff, and then I'll explain what I mean. And we have seen this a couple of times in the course already. So here, I'm going to define these things to be these names. Actually, I'll see what happens if I do it in lowercase, and then I'll say a few things. Okay, so I'm going to try compiling this code, and you'll notice it does compile, and it actually also runs. So, I mean, the code seems to work. So what have I done here? This strange incantation, #define, is telling the compiler that I'm going to make up a name for something. So when you write #define and then a name and then some value, what you're telling the compiler is every time it sees this name, just to copy and paste in this number. So every time it sees the word rows, it just pastes in the number 4, everywhere in the program that it sees it. This is distinct from what happens when you declare a constant variable, because this is just a copy and paste exercise. The compiler is just doing substitutions for you. It's not creating anything inside of a scope, and in general, you could use the name rows or calls anywhere in the program. There's no scope inherent to this. These are called constants, named constants, just like constant variables are. Often they're called preprocessor defined constants. Traditionally, as a convention, if you define a constant using this notation, you give it an all uppercase name, because that way programmers that read the code, if they see an all uppercase name being used, they assume it was a constant defined using that notation. So I'll try that just for the sake of making it consistent. I do use #define constants a lot in code that I write, but I try my best to use const variables wherever possible. But in this case, it didn't work, so I had to find some alternative. So for the best of both worlds, I really don't want to have to write 4, 3 here, because that means that I have an inconsistency risk if I change the number of rows and columns. So the 100%, I think, best practice way of writing this would be to use named constants with hash define. In this course, you're welcome to use this, although you're not going to be tested on it, because it's something that if you use the const qualifier on a variable judiciously, rarely is it that you'll need these at the level of C code that we're writing in this course. Okay, but in any event, I think we are now done this exercise. So let's go back and take a look at the next one. So this was the one that it labeled exercise 2, but I did it first because I asked for a bunch of clarifications. So we'll scroll down, and then it suggested 2 more exercises. And so one of them was sum of elements in a 2D array. And at the time I observed, this does seem a little bit basic, but whatever. I mean, I asked for it, I guess I should do it. So we'll copy that, we'll go over here, I'll paste the exercise into a new file, and what I'm going to do is actually go steal the array from my last exercise. And I'm very quickly going to regret that, I think, because now that I think about it, I don't want to figure out what the sum of this is. I'd rather not compute this on the side. But whatever, here's my array. I will even, just as a testament to the fact this is a bit of a basic exercise, I'm actually going to steal quite a bit of my infrastructure from my previous exercise here. Okay, so I've got this loop that loops over the array. What I'm going to do is I'm going to write a loop very similar to one that I would use to sum up the elements of a one-dimensional array. I'll create a variable to store my sum in advance, and then I will, at each step of my array, each step of my loop, I will just go through and add the value of the current element to the sum that I'm computing. So there we go. I go grab the element at row j, column k, and I add that into my sum. And then at the bottom, I'll just print that out. So printf, the sum is, and then print out the sum. Now, for testing purposes, I've got a couple of issues here. So I could compute the sum of this. I mean, why not? Let's just try it out. I don't know if I want to validate the sum of that array because it looks like it's something I can't compute in my head. So we'll try running it. Practice 2D arrays 2. The sum is this number. Okay, well, that's not very meaningful to me. So what I'm going to do is install some new values that are going to make it easier for me to compute the sum. So I'm going to include a mixture of positive and negative values, and I'm going to choose numbers that for me as a human are pretty easy for me to add up basically in my head. And I would argue that yes, these are very nice round numbers, but there really is no reason that the program should care about that. So it is reasonable for me to choose numbers that are easy for me to validate, I think, for that purpose. Okay, so we'll do that. We'll try saving it. Okay, so the sum of the first row is 6 because it's 6 plus 1 minus 1. So then the sum of the second row is 20. So I now have a running total of 26. And then the sum of the third row is 103. So I should be at 129. And then here I get to 136, 145. Sum is 145. Okay, so that looks good. And again, because if I look at the loop, I can be careful when I do my debugging, when I do my testing, I can evaluate my code to decide what exactly is it I have to test. In my opinion, the actual magnitudes of these numbers aren't really the problem. Like, it doesn't really matter whether this was a 10 or an 8. I think the loop would be able to add it in correctly. The question I need to be able to answer is, will this code work correctly if anything else changes? So I will do one more test changing the numerical values. Currently the sum is 145. What happens if I change this to negative 10? Well, I mean, then, just to be clear, it was 10, which means the sum is 145. If I change it to 0, the sum will be 135. If I change it to negative 10, the sum should be 125. Okay, and it is. Okay, so I think that's enough to demonstrate that the actual numerical values seem to be being added correctly. Now let's try changing the number of rows and columns, and I'll leverage that named constant I created for this. Let's change it to 3 rows and 3 columns. Okay, so the sum previously was 125 in the current version, and I'm eliminating 16 from that sum. I'm actually just going to comment this out. So now the array only has 3 rows and 3 columns. So I get rid of 16, it should be, what, 109? Yeah, okay, so there's 109. It looks like that worked. Let's see what happens if I set the number of rows back to 4, but I now have 2 columns. Okay, so I may have to recompute this one. So I've got 2 columns now. I'll All right, so that should be 7 plus, well, 0, because this row just cancels out. So 7 plus 0 plus 101 brings us to 108, plus another 7 is 115 by my reckoning. Okay, and that looks good. And then finally, let's try reducing the number of rows to 3 and the number of columns to 2. The sum is 108. Does that make sense? So that's 7 plus 0 plus 101. Yes, it does. Okay, so there's my, and I think we can call it for this exercise. So there's my exercise that computes the sum of the elements of a 2D array. The array has type int, but I'll bet maybe you'd agree too that if I were to change the type of the array to double or float, and obviously change all of the variables that I'm using in the meantime, that I'd probably also have correct code for that. All right, so let's go back and take a look at the next exercise that was suggested. So it then suggested finding the transpose. This was the second time it did that, and I wasn't having any of that. So eventually it got to this new exercise 3. To solve this, I'm going to have to make a couple of assumptions. And this is an exercise that I'm actually really pleased by this. Like I'm very excited to do this exercise. One observation I'll make though is that this exercise is dangerously close to a topic we're just about to cover but haven't covered yet, a topic of strings. But it isn't actually a string exercise. The assumption I'm going to have to make that you may not be aware of yet, but soon in the course you will see this, has to do with what values a character can take on. And I'm going to use a special type, the type char, for that purpose. All right, so it takes a 2D array of characters as input. Now, just like before, and I sort of have to do this because otherwise we're stepping on our next topic. Just like before, when it says as input, I'm actually going to hard code the array into my source code. I'm not going to try and read the array from the user. And there are a few pragmatic reasons for that. One of them is that we haven't yet seen some of the machinery we would want to use to read characters like that from the user for the sake of reading them into an array. And the other one is that it would require quite a few somersaults as far as being able to do testing, just like before. I don't want to have to enter a 2D array in every single time. It does suggest an input array to use just for the sake of testing. I am going to use this input array so that I can verify it against the output that it provides. It then says what the program should output. So what it seems to want is you enter this 2D grid of characters, and then it goes through and counts up how many times each character occurs, and then prints them out. So there are 2 H's in this 2D array, and you can see it prints out there are 2 H's, there are 2 E's, there are a total of, okay, so in this array I'm counting 5 lowercase l characters, and it's printing out that there are 3. I think ChatGPT doesn't know what it's doing here. So I'm going to take this as an example of the correct format of the output, but I have a feeling that ChatGPT doesn't know actually how to answer this problem itself. So I'm going to use this as my input array, and we're going to sort of be left to our own devices as far as what the correct output should be, but it should be in this general format. All right, so I'm going to copy this exercise over. We'll go to practice 2D arrays 3. There it is. We'll just format this. Okay, I didn't copy it somehow. Okay, so I'm going to try and copy this exercise over. There we go. And then paste it in. There we go. And then we'll just do some reformatting. Now, what I'm going to do is I'm going to use a similar technique to what I did in the previous couple of exercises. I'm going to make up an array that's hard-coded into main. It looks like the one that ChatGPT suggested was 3 rows and 5 columns. And for my array, I could use type int for this. Maybe I'll start by trying out type int. So it's got dimensions rows by calls. And then I'm going to have to fight with it about the indentation, aren't I? Yes. Okay, so the array was the word hello. And then the second row was the word world. And then the third row was the word hello again. And you can bet I'm going to copy and paste to get that effect, because typing in these arrays by hand is a huge pain. There we go. Okay, and then the third, let's see, the third row is just the first row again. Okay, and then if I fix up the indentation a bit, let me get this. And then finally we have this. Okay, so here's my original array. Now, we can use type int for this, and we saw earlier in the course that when we work with character data, we store each character value in an int because the character is just a number. I am going to now skip ahead a bit. Maybe by the time you watch this, we've already had a lecture about this. I'm going to use a different integer type. So just to remind ourselves what integer types exist, we've got the classic int type. If I want more range, I've got the long int type. If I want even more range, I've got the long int type. But if I want, I can create variables with less range. So for example, I could create a short int. And there's an even shorter integer type called char. And remember that char is an integer type. It's a regular number. It just happens that the type has an extremely small range. Typically, it's the case that the char type has a range of, there are a total of 256 different values that can be stored in chars. In a classic char variable, the range of possible values is -128 through positive 127. And here's where I'm going to make an assumption. So I'm going to use type char to store my characters so that I can make this assumption, and I'm going to make my array an array of type char. And this gives us also a good excuse in this video to have arrays of type other than int. Okay, so next assumption. The next assumption I'm going to make is a little bit dangerous. It's a simplification I have to make for the sake of this video because the exercise really can't be done otherwise. And it's to avoid having to worry about things like what are called unsigned types, which is something we don't necessarily want to deal with today. The assumption I'm going to make is the following. It is that, and this is something is a reasonable assumption to make in this context, but a little bit risky in general. The assumption I'm going to make is that all of the characters I can produce on my keyboard have character codes between 0 and 127. So there are 128 possible character codes that I could enter. We've already seen things like the character code for H is, or the character code for lowercase a is 97, and we could try this out. Let's do char lowercase z. And I'll print out the character code for this thing is this thing. And I'll print out, we'll call this char C. He'll print out C, and we'll print out C twice, once as a character, once as a number. We can obviously ignore that warning. Practice 2D arrays 3. The character code for Z is 122. We know that the uppercase letters have character codes beginning around 65. So the assumption I'm going to make, which is again a little bit dangerous because maybe there are character sets out there that don't have this property, or maybe there are some aspects, some weird low-level things that I'm not getting into today. The assumption I'm going to make is that all the character codes I'm going to work with are going to be between 0 and 127 inclusive. And as I said, notice how lowercase z, which is one of the later characters you're going to see with the higher character codes, is positive 122. It goes without saying that this exercise is too complicated for a midterm, and were it to show up on an assignment, you would get a lot of guidance as to what assumptions you could make. I should also add that one of the topics we haven't seen yet, so structure types, would provide us a much more flexible way of handling this, but we haven't seen it yet, so I've got to make do. Okay, here is what I need to do. I need to produce what amounts to sort of a histogram. So I look at all the characters in this 2D array, and I develop a count of how many times each character occurs. So there are 2 H's. So I print out there are 2 H's. And I'm going to argue for this exercise, because of the way it's phrased, it should count and display the frequency of each character present. It doesn't say what order I display the characters. So maybe I'll go in alphabetical order, or maybe I won't. It doesn't seem to make much of a difference. Okay, so there are 2 E characters. I'm counting 1, 2, 3, 4, 5 L characters. Okay, and then there are, I forgot D. Okay, so there is, I think, only 1 D character. There are, I've already done E. I need to do O, so there are 3 O characters, and there is 1 R and 1 W. So the output I expect to see is this. We noticed a few minutes ago that ChatGPT had a problem with its output. Don't worry, I'm going to go back over there and rub it in a minute once I have my own code working. But the key thing is, if it gives you model output, you could use that as a guide, but you should always be able to produce the output yourself. If you don't know, if you can't work out by hand what your program is supposed to do, how in the hell are you going to get your program to do it? So I should be able to work out an example by hand, and I can then use that as a basis for testing my own code. Now, how am I going to do that? I'm going to use an array for that purpose. And I'm going to use, this is probably a use of arrays that you haven't seen yet and maybe have never considered. And that's why I think this is a really interesting exercise. It's pretty tough, though, if you've never approached a problem like this before. So I mentioned a minute ago that I expect that every character I see will have a character code between 0 and 127 inclusive. So I'm going to make an array of size 128. So that means the last index will be index 127. And the idea behind this array is that each index of the array counts how many times I've seen that whatever character code it corresponds to in my input. So let me just, well, this is about as well aligned as I can expect. So for example, suppose now we happen to know that uppercase A has index character code 65. So what I'm going to do is I'm going to use index 65 of my array as a way of storing how many times have I seen uppercase A. And what's clever about this, I think, is that it's really easy to take a character and treat it like a number. I could index into my array at index 65 because we know that if I create a variable and I set it to uppercase A, so if I have char C equals uppercase A, the real value of C is the character code for A. The number is 65. And in this exercise, I'm going to leverage that. I'm going to index into my array using the character code. I will check, though, that the character code is between 0 and 127, because in the event that assumption was wrong, I would want some feedback on that. Okay, so what do I do to get this effect, to achieve this effect? Well, the first thing I need to do is create this array of counts, this sort of histogram array, this frequency array. So I'll do that here. I'm going to make it ints, because int is a good type to use for counting things, frequencies. And it's going to have size 128. I'm going to use this initializer to initialize all the counts to 0. So remember that if I just write this, line 25 as it currently stands, creates an array that's full of random garbage. I want to count things, so I'm going to set all of the counts to be 0. By using a curly bracket initializer, even if it's incomplete, even if there are fewer things in the curly brackets than the size of the array, once I initialize any of the array, the whole array gets initialized. So the whole array is going to get initialized to 0. And to be clear, even if I wrote this, so if I wrote like 6 or something, the thing in the curly brackets gets used to initialize however many elements you provide. So this would say initialize the first element to 6. And if I provided 2 elements, it would be initialize the first element to 6 and the second element to 10. All other elements also get initialized, and they're always initialized to 0. So just because I write this doesn't mean I'm saying this 0 means every element gets initialized to this value. It's just that the first element gets initialized to 0, and all other elements get initialized by default to 0, regardless of what I put inside the curly brackets here. Okay, so now what I'm going to do is loop over all of the characters in my 2D array. I think for the sake of the program making sense, I'm going to print out the 2D array first. The character grid is, and then I'll just print out the character grid with some loops. So I'll say for int j equals 0, j is less than the number of rows, that's all caps, j++, and then, and then similarly inside of that, I'm going to do for int k equals 0, k is less than the number of columns, k++. There we go. And then I'll just print out each character inside the grid, followed by a space. And then that's going to be a at j, k. And then at the end of this, I'm going to print out \n. So what I'm doing here, this inner loop is printing out everything inside of a row, and then this \n is happening at the end of each row. So I get an actual grid, and I'll try running that. Obviously, this warning we can ignore because I haven't gotten around to using it yet, and then I'll run it, and we can see there it is. There's the character grid. It is printing everything out. Okay, so that might help me when I'm doing my testing. Okay, I'm actually going to move down the declaration of this array to down here. There we go. And now what I'm going to do is I'm going to loop over my character grid again. And for each element, each character that I see, we already see how to access each character. Maybe I'll expand this to a few lines. So char C equals that element of the array. And I'm about to do something rather odd. What I'm going to do is use the numerical value of my character C as an index into my array. So actually, I'm going to use an int for this because we like indexing using ints. I'm now going to ask the question, if c is less than 0 or c is greater than 127, well, that means my assumption was violated. So earlier I said, I'm going to assume that every character has a code between 0 and 127. And I think I'm justified in that. Like maybe I have expertise or I have other pre-existing knowledge that this is going to be the case. I mean, otherwise, why would I be doing this? But even so, it doesn't matter how sure I am of this. If I make an assumption, it's always good to add code to check it. Because in the unlikely event that I am wrong about it, if I don't check for it, I might just get random behavior that I don't understand. So even if I'm absolutely sure of something, when I make an assumption, I should include some logic to test that assumption. Invalid character code, and I'll just print out the character code as a number, and then I'll exit the program because I can't continue. I don't know what to do if my assumption is violated. It means that my design methodology, I guess, was wrong. Okay, but otherwise, if I get down to line 42, it means that the value of c is between 0 and 127, which means it can be used as an index into this frequencies array. So I'm going to do this, frequencies sub c plus plus. Well, okay, I'll do plus equals 1, just because that plus plus there might look a little bit too weird for some people that are watching. Okay, frequencies sub c plus equals 1. Okay, so what I should have now then is in each element of the array, so if we look at, let's say, the element for uppercase A, I'm going to add 1 every time I see an uppercase A. If the character that I get, if c is uppercase A, I index into my frequencies array at that index, which happens to be this number, although you'll notice nowhere in here do I actually use the numerical value myself. I assume the character has some numerical value and I just use that. And then I add 1 to whatever element I have in the array, so this frequency value. And now I have to print that out. I'm going to clear this. Now I have to print that out. So what I apparently want is only to print out the characters that have a count that's greater than 0. So I'm going to loop over all the frequencies. I'm going to use a different index for this. I'm going to do maybe int n. Int n equals 0. N is less than 128, n plus plus. And it appears from the output ChatGPT gave me, although the actual values were wrong, notice that letters only show up here if they actually appear in the grid. So the letter A doesn't show up. And I'm going to follow the same convention. So the way I'm going to do that is I'm going to say if frequencies at index n is equal to 0, I'll just only print it if it is greater than 0. So if the frequency is greater than 0, then I'm going to print something out. What am I going to print? I'm going to print out, well, let's see, the character version, the character code, and then the frequency value. Okay, so I'll print out a character, a colon, and then the frequency value. Now here, to be one thing that might be a bit confusing, if this is not already sort of confusing, is if I'm using my array of frequency values, and I have, let's say, the frequency for number index 65, that would be uppercase A. Notice how the character itself is the index that I'm using. In other words, the character would be the value of n. So that's what I'm going to print out. I'm going to print out n as a character with %c, and then I print out the frequency value at that location, frequencies sub n. All right, so I'll save that, and I think I'm ready to try it out. Okay, no compiler issues. All right, so the character grid is, and then I see, let's see, so hello world, hello, that looks good. I notice an odd amount of white space there. That's something I might want to worry about a little bit later. But then I see, okay, D1, E2, H2, L5, O3, R1, and W1. And I think that looks pretty good. So the reason I think that is because if I add everything up, so okay, 1 plus 2 plus 2 plus 5, that's 10, plus 3 plus 1 is 15. And there are 15 total characters in my grid. So that's a good sign. That's a sign that I am printing out, that I am taking into account all of the different characters in my grid. Now, what's interesting, though, is if I go back over to ChatGPT's output, it's in a different order, and it's gotten some stuff wrong. So here, if I add up, okay, so 2 plus 2 is 4, plus 3 is 7, 8, 9, 10, 11, 12. Okay, so here is where I can gloat. I'm going to do more testing, and then I'm going to do my gloating. So let's see what happens if I add some more characters to my output. All right, so we'll go up here and just change. I guess I'll see what happens if I add another row. So here I'm going to set rows to be 4. and I've got to think of something that fits in 5 characters. I can't think of anything, so I'm just going to default to something obvious. So ASD F. And notice how these are capital letters. And capital letters are distinct from lowercase letters, so I should expect to see capital A, capital S, capital D show up separately. I'll leave in that lowercase d there just to see what happens. Previously there was 1 D in my output. There now should be 2. All right, so there we go. And I see, okay, A, there's one of them, D, there's one of them, F, there's one of them, S, there's one, and then I've got lowercase d, there are now 2, it's these 2. I've got lowercase e, there are still 2 of them, it's the 2 E's in the words hello. I've got still those 5 L's, and all the uppercase letters are up here, so nothing else is any different. It's also worth noting, interestingly, that the letters are actually coming out in alphabetical order, sort of as a nice pleasant coincidence. Let's see what happens if I remove, let's go back to having 3 rows, and then I'm going to remove a column. Okay, so now there are 3 rows and 4 columns. And we'll try testing that out. All right, so, okay, we'll just scroll down here a bit. There we go. Oh, whoops. Okay, so we take a look at this. So I've got, let's see, I've got the letter E appears 2 times, the letter L or the letter H appears 2 times. Okay, actually, you know what? Before I test anymore, what is this gap doing here? Where is all this white space coming from? So let's do a little bit of debugging. So, okay, if I notice a bunch of extra white space, if this was like 1 extra space, I think that was great. I mean, even if it was an accident. But if I'm noticing a bunch of lines of white space, I should be a bit suspicious. That might mean I have a bug in my code. So then the question is, where is it coming from? I think I know where it's coming from already, but if I didn't, what I could do is add extra print statements every now and then and see, I could use that to sort of isolate where in the code it's coming from, but I think it's this. So here, I wrote this loop up here to print out the character grid, and then later I copied and pasted it to create the loop that computes the frequencies. When I did that, I forgot to delete this print statement. So this loop that's just supposed to be doing calculations is also printing a bunch of junk, which I don't want to have happen. So it's printing out these \n's, which means I get this weird set of padding between the 2 parts of my output. So I'm going to delete that and then run it again. Okay, now there we go. Okay, so that removes the white space. Now, I've got everything on one screen. So there are 2 E's, there are 2 lowercase h's, there are 5 lowercase l's, there is 1 O, there is 1 lowercase r, and there's 1 W. And I'll do one last test. So I'm going to go back to having my my 5 column array, so we'll set columns back to 5. What I want to do is I would like to test this with more uppercase letters. So one more time with uppercase letters. Actually, I also want to see what happens if I use characters that aren't letters. So we'll do H, E, L, L, O. And then down here on this last line, I'm going to do, actually I'll capitalize WORLD. So I want to test out the case where there are uppercase letters and also where there are at least 2 of some letters. So here, there's going to be 3 uppercase L's. On this last row, I want to see what happens if I use strange symbols. So there's the hash symbol, there's the @ symbol, there's another @ symbol, I guess, just to make sure we can count more than one of them. How about we do the asterisk, and then I'll do the digit 6. Okay, so just a bunch of characters that aren't letters. I want to see whether this still works. I don't know if I have to make it work in this case, but it's still, I think, useful to test it out to see how resilient the code is. There we go. Okay, so I look at my grid. Okay, there it is. That looks good. There is 1 hash symbol. Okay, yep. There's 1 asterisk. There's the digit 6. It appears once. I've got 2 @ signs. It's weird the order these symbols show up, but fair enough. I've got 1 uppercase D. That's this. I've got 1 uppercase E, 1 uppercase H, 3 uppercase L's, 1 uppercase, or 2 uppercase O's, an R, and a W. All right, now I'm going to go all the way back to my original because I now want to give ChatGPT a hard time because it can't do this task. Since this was clearly a pretty arduous process, one of the parts of celebrating that I was able to complete it is gloating a bit that ChatGPT, an apparently all-powerful computer system with thousands and thousands of hours of computation and horrendous amounts of memory and all of the knowledge of humankind at its disposal, couldn't solve this exercise. Obviously, gloating on that front is going to increase my confidence a bit. It's not necessarily a good idea to bring others down because you want to build yourself up, but ChatGPT isn't a human, it's a computer, so I think we can write that off a little bit. Okay, so there I go, I have this again, and I'm noticing, of course, that there are 5 lowercase l's. There we go, 5 lowercase l's. And in the spirit of competition, let's go and rub that in ChatGPT's face. So the output you provided is incorrect. Your output says there are 3 L characters, but there should be 5. You're absolutely right. I apologize. Okay, so now it's come up with this, 2252111. So 2 H's, 2 E's, 2 O's. Okay, I don't know about that. So we go back over to the output that we now believe to be correct. We've done a lot of testing. There are 3 O's. So one thing I've observed before about ChatGPT is if you make a leading statement, if you say, I think this is wrong, or I think this is right, or I think you have a bug on line 17, it seems to want to agree with you, even if it doesn't actually have any way of validating your statement. You can tell it it's wrong about something that isn't incorrect, and it may still say, oh, you're absolutely right, and I apologize for the mistake. Okay, so there are 3 O characters, and you said there were only 2. ... I apologize once again. Okay, well, let's see. So 2 H's, 2 E's, that sounds good. 5 L's, that sounds good. 3 O's, okay, that sounds good. But is it possible, so this is correct. I think this is correct. I'm going to try an experiment. I'm going to make up a mistake. I'm going to give it erroneous data and see what it says. There should be 5 H characters, and you said there were only 2. I want it to correct me and say, no, there actually are only 2. You're lying. Yeah, so see what I did there? I lied to it. I made up a false statement, and it just said, oh, you sound so confident. It sounds like you're really telling me I'm wrong, so I'm sorry. Here's the corrected output. Okay, how far can I take this? That's good, but you said there were 2 E characters, and there are actually, 6,000 of them. I apologize for the confusion. Okay, let's correct this. And it now says, yep, here's the input, just so in case we forgot the input, the correct output should say there are 6,000 E characters. Okay, that's almost right. But actually, there are 7,000 of every character. Let's say 6,000. Not just E. I apologize for the confusion and the error. Oh no. I apologize for the confusion and the errors in my previous responses. Poor ChatGPT. Okay, so I feel like I've been mean to ChatGPT now. ChatGPT, I've told it, yeah, you're wrong. I'm sort of gaslighting it, I guess. But you'll observe this is one reason ChatGPT isn't always the most helpful if you want interactive practice, which is it's great at suggesting exercises, but if you have any questions that are more involved, that are beyond definitions, it gets really confused, and it doesn't seem to understand what things you're asking that it needs to verify. And also, it has no way of verifying. That's not its job. Its job is to speak convincingly. It's a language model. It's very good at writing grammatically correct sentences that you can follow, but it doesn't necessarily actually know any facts. And those of you that are using it probably realize that when you log in, it gives you a warning saying, look, if this thing tells you any facts, it might be lying to you, so you better go check them yourself. And that means, because it's a language model, if I were to say these leading statements and I sound confident, oh, there are 6,000 of every character, it just says, oh, okay, and then it just changes its output to match whatever it thinks I wanted. Strangely, it actually didn't do what I asked. It just generated weird random junk, but it'll basically attempt to adapt to whatever I tell it, even if I'm wrong, even if I'm deliberately lying. It turns out I was lying about much of that. Your output was pretty much correct initially. Sorry. I don't know, I feel a little bit bad. No problem at all. ChatGPT is very accommodating of this sort of experiment. Well, that's definitely good to hear.